Hello guys, my name is Dimitro, and today we're gonna solve number 17, which is find the maximum, minimum, and saddle points of fxy, if any, given that for part A we have 2x, or partial of x, which equals 2x minus 4y, and partial of y, which equals 2y minus 4x. But we gotta find the critical points. So we say each is equal to 0, right? Some simple algebra. You just do yeah, I'm on the right track.
Yeah, so you have a travel card, right?
You guys see that?
No, like the
Then we have, so we plug that into here. So we have 4y minus 4x, which is just 0. And then,
no, it's fine. So we'll have to request when ASAP.
wait,
I just don't have time, but it'll
oops,
be okay.
I did it wrong. 2, plug it into here. So we have 2y minus 6y equals 0. Which is negative 4y equals 0, y equals 0, therefore x equals 0. So that's our critical point.
It'll be either Uber to a car rental place nearby to you.
But we still need to find the maximum, minimum, and saddle point. So we set it in the determinant form. Or actually, we're gonna find the partial of x of x, which is just 2.
Oh, okay.
Partial of x and y, which is just 0. And partial of y, which is just 2 as well. So I saw where I messed up. My s of xy is just negative 4. But it could be y of x, which you'll get the same thing. But either way, you'll have 4, negative 4, negative 4, 2, which is just 4 minus, wait, yeah, 16, which is negative 12. Therefore, our s of 0, 0 equals negative 12 is a saddle point. Since our d of 0, 0 is less than 0, right? That's for part A. Now for part B, we do the same process. xy minus 2 equals 0, and 2y minus 4 equals 0. You could solve for either one, but you should get the same thing. You get 1 right here. 2y equals 4, y equals 2. So our critical point is just 1, 2. Now we gotta do partial of x, which is equals 2, right? Partial of xy equals 0, and yx is 0 as well, and partial of yy is equals 2. So we put it in determinant form. We have our 2, our 0, 0 again, the partial of yx, and then 2, which just equals 4. Therefore, our s of 1, 2 equals 4 is a minimum point because our d of xy is greater than 0 and our fxx is greater than 0. This is our f of x, or partial of xx. This is our determinant. Okay. Or actually, it's a local minimum point, but you guys get me. All right, now for part C, same process. You do 9x squared minus 0 equals 0, and 2y plus 49 equals 0. But, I mean, you could solve for either one. 9x squared just equals 1, x equals plus or minus 1. We have 2y equals negative 49. They did it. Yes, never mind. So I have y equals negative 49 over 2. So our critical points would be plus or minus 1, comma, negative 49 over 2. Now, same thing. That would just be 18x. So xy would be 0. F sub yy would be just 2. Now we put in determinant form. Same thing. 18x, 0, 0 again, 2, which is just 36x, right? Now we gotta test these points to here. Thankfully, it's only an x value, so we only have to do positive 1, negative 49 over 2, which equals just 36, negative 1 would be negative 36. So, therefore, or actually, I'll do it here. D of 1, positive 1 of 49 over 2 is a local minimum, since it's D is greater than 0, and D of negative 1, 49 over 2 is a saddle point. Since D of negative 1, 49 over 2 is less than